All right, we're going to talk about rational expressions and rational functions. Again, this is going to be a little bit different section number than the section number that you see in your workbook. In our new book, this is going to be section, I think it's in chapter 7. So don't pay attention to these section numbers. You are looking for the topic, rational expressions and rational functions. So let's talk about what a rational function is. What a rational function means is that it's just a function that can be written as a fraction. So rational functions and fractions are pretty much the same thing. Remember that in a fraction, it is a no-no to have 0 in the denominator. So we're going to make sure that we don't have 0 in the denominator. We're going to talk more about that a little bit later. But right now, let's determine some values. So in the first 3 questions, it gives us a function notation f of x equals x plus 3 over x minus 4. We haven't talked a lot about functions yet, but what that just means is that in the parentheses, I'm going to give you a number that I want you to substitute in for x in the equation and then work it out. So if I'm doing f of negative 1, that means I want you to take negative 1 and I want you to put it in for every x in that function. So that means I'm going to have negative 1 plus 3 over negative 1 minus 4, and then we're going to work it out. Negative 1 plus 3 gives me a positive 2. Negative 1 minus 4 gives me a negative 5. So negative 2/5 would be the answer for that one. Okay, the next one says find a f of 0. So again, I'm going to take 0 and I'm going to put it wherever there's an x. So 0 plus 3 on top, 0 minus 4 on the bottom. That gives me a 3 on top and a negative 4 on the bottom. And when we write these answers and we have a negative with either the top or the bottom, you could write that negative out front like that. Or a lot of times I will write it with the top number for a final answer. It doesn't matter. It's correct either way. But most of the time you see those negatives either out in front or up with the top number. Okay, in this next one, you're going to have a 4 to replace x with. So that's going to be 4 plus 3 over 4 minus 4. Well, I'm going to get a 7 on top, and 4 minus 4 gives me 0 on the bottom. That means that that answer is undefined because we can't have 0 in the denominator of a fraction. Now, that's going to come into play when we do the next steps, finding the domains. When we're finding the domains, we are trying to find the numbers that we are able to use in our rational function. So that means that we're only going to have to look at the denominator, whatever's on the bottom. Doesn't matter what's happening in the numerator, strictly looking at the denominator. And what I need to do is, if it's not factored already, I need to factor it. So you need to factor the denominator. And then set each factor equal to 0. And solve them. Those are going to give you the numbers that you need to avoid. So a lot of times in ALEKS, or if you're using ALEKS, or if you're using a different software, it'll tell you numbers that you need to eliminate from your answer, and finding the domain numbers are the numbers that we need to eliminate. So in their example, you can see that they have x squared plus x minus 42 in the denominator. When they factored that, they got x minus 7, x plus 6. Well, then you set each one of those equal to 0. So your x minus 7 equals 0. So you'd add 7 to both sides, and that's where they're getting 7 from. And then the same thing when they have x plus 6 equals 0. You subtract 6, and that's where the negative 6 is coming from. So on this one, we need to stay away from 7 and negative 6. So if you're just asked to eliminate the numbers, you're just going to put list. You got to stay away from 7 and negative 6. If we're going to use different notations, then set builder notation would just mean that you just list them. X cannot equal negative 6, x cannot equal 7. Sometimes you'll list them in the homework with just 6 comma negative, or I'm sorry, negative 6 comma 7. Just separate the answers with a comma. If you're asked for interval notation involves using the number line to show the numbers that are not included. We're going to do a lot in the next chapter with interval notation, but for our purposes, what this means is that if we can include -6 and we can include 7, that means I've got a gap on the number line. I can use any number to the left of that open circle. I can use any number in between. I can use any number to the right of that open circle. And the way you show this using interval notation, remember this number line is going from -infinity to infinity. So when I am writing my interval notation, that means I'm coming from -infinity to -6. I can go from -6 to 7, and then I can go from 7 to infinity. Now, I think that mainly your homework is going to ask for your answer with your numbers listed. So we'll talk more about interval notation at a later time. Okay, so let's look at these next ones. If I'm going to find the domain, I'm going to look just only at the denominator. So I'm going to take x squared minus 4. I'll set it equal to 0. So I'm going to factor. That's the difference of two squares. So that's x plus 2 and a minus 2 equals 0. So if I set each one of those equal to 0, I'm going to get a -2 for one answer. If I set x minus 2 equal to 0, I'm going to get 2 for my other answer. So a lot of times you're just going to answer it -2 and 2. If I wanted to do interval notation, I would do similar to what I did before, but I think for our purposes, you're just going to have to list it right now. Okay, number 5, we've got an x squared. Notice I'm not even paying attention to the numerator because the numerator just doesn't matter on domains. I'm only looking at the denominator because on a fraction, you just have to worry about 0 being in that denominator. So I've got x squared minus x minus 12. So I'm going to factor. So the factors of -12 that add up to a -1 would be -4, +3. And there may come a time when I'm just looking at those two parentheses, you may do the same thing, and I can tell you what my two answers are before I even set those equal to 0. My two answers are going to be 4 and -3. But how we get that is we take x minus 4, set it equal to 0, add 4 to both sides, so you get 4 for an answer. X plus 3 equals 0. Subtract your 3. I'm not always showing this step. I need y'all to let me know when we have a question and answer session about whether or not skipping steps is okay with you. So there we go, 4 and -3 for that one. Let's look at a couple more of these. If I've got x squared plus 3, if I set that equal to 0, I need to look at that and see if I can factor it. Well, 3 is not a perfect square. I have an x squared. I don't have an x cubed. I cannot factor x squared plus 3. That means that my domain for this one would be all real numbers. Because if I can't factor it and set anything equal to 0 and get an answer, that means that I can use any number that I want to, and I would be okay. You cannot get 0 in the denominator of that one. Number 6 is, again, the difference of two squares. I'm just going to do this one real quick. X plus 6 and x minus 6 on the bottom. So my two numbers that I couldn't use would be 6 and -6. Okay, now let's look at the 2 at the very bottom. If I'm looking at 2 over x, what is the only number that I can't have in the denominator of a fraction? The only number I can't have in the denominator of a fraction is 0. So on this one, there's nothing to work out. There's no expression to factor. X can't be factored. X is just x. So x equals 0. So I can't use 0. So if we're doing set builder notation, you do it x cannot be equal to 0. If you're just listing it in the homework, you just list 0 for a number you've got to leave out. The same thing for 1 over x squared. If I set x squared equal to 0 and I try to solve that for x, I'm still going to get 0 because the only number squared that will give you 0 is 0. So again, on this one, x cannot be 0. That would be the domain. All right, so simplifying rational expressions. The key to simplifying rational expressions is to know how to factor. You have to be able to factor to solve these rational expressions. Okay, so on the first one, number 9, there's really not any factoring to have to do. You'll notice in their example, they had to take the top part and they factored it. They took the bottom part and they factored it. And then the way you can simplify it is you find matching parentheses once you have factored. Or you can say matching factors. So, but those parentheses have to exactly match before you can start canceling things out. So let's look at number 9. Sometimes they can be as simple as using our exponent rules. So if I look at number 9, I see that I've got 6 over 12. Well, 6 goes into itself 1 time. 6 goes into 12 2 times. So I have a 1 over 2. I'll come over here and write that. I've got an x squared on top and an x to the 1 on the bottom. Our exponent rules tell us that when we divide, we subtract exponents. So 2 minus 1 would be 1. So I have an x to the 1 left on top. All right, for the y's, I've got y to the 5th on top and y to the 9th on the bottom. 5 minus 9 would be a negative 4. And we're going to simplify that a little bit more in just a second. Okay, look at our z's. I've got a z cubed on top and a z to the 7th on the bottom. 3 minus 7 would again be negative 4. Now, if you remember from exponent rules, you can't ever leave exponents that are negative in a final answer. They have to move from either the numerator down to the denominator or vice versa. So in this case, I have a 1 on top. I have an x on top. That x is fine. It has a positive 1 exponent. The y to the negative 4 is going to need to go to the bottom. The z to the negative 4 is going to need to go to the bottom. I have a 2 down there already from when I simplified 6 over 12. So the y to the 4th comes to the bottom and becomes a positive y to the 4th. The z to the negative 4 comes to the bottom and becomes a positive z to the 4th. So that's how you take care of the negative exponents. You're going to see more like number 10 when you're working your homework problems. I've got y squared minus 3y minus 10 on top, y squared plus 2y minus 35 on the bottom. I'm going to go ahead and do the factoring part. I'm not going to go through all the steps to factoring. That is something that you need to go back and review factoring if you have trouble with it. I need factors of negative 10 that add up to a negative 3. So that would be negative 5, positive 2 for the top. On the bottom, I've got y squared plus 2y minus 35. So I need factors of negative 35 that add up to a positive 2. And so that would be positive 7 and negative 5. Okay, now you can see I have a y minus 5 on the top and a y minus 5 on the bottom. So I'm going to cancel those out. Now, I cannot cancel out a y plus 2 with a y plus 7 because those two numbers do not match. 2 and 7 don't match. You can't cancel out just the y's because these expressions have to exactly match. Think about putting numbers in for those y's. If I put a 3 in for y, that means I'm putting a 3 in the top and a 3 in the bottom. 3 plus 2 would be 5 on top. 3 plus 7 would be 10 on the bottom. 5 over 10, that doesn't equal. 5 and 10 don't equal each other. So I can't do any canceling like that. So my final answer is going to be y plus 2 over y plus 7. And that's as good as it gets. Okay, let's look down at the next one. Factors of 48 that add up to 14. Let's do 8 and 6. So y plus 8 and y plus 6 over factors of 64 that add up to 16 would be 8 and 8. So y plus 8, y plus 8. So again, I have a y plus 8 on top, a y plus 8 on the bottom. I can't cancel out y plus 6 and y plus 8. So y plus 6 over y plus 8 would be my final answer. Okay, number 12 gets into It's into a factor by grouping on the bottom. On the top, factors of negative 21 that add up to a negative 4 would be negative 7 and a positive 3. Okay, on the bottom, I'm going to group it underneath here. I'm going to pull out an x squared and have an x minus 7 left. I'm going to pull out a negative 10 and have an x minus 7 left. So for the factors of this, I'm going to have an x minus 7. And then remember, the two factors that you pull out in the middle go in their own parentheses. X squared minus 10. So on this one, the x minus 7's cancel. I cannot cancel the x with the x squared. Remember, this whole parentheses goes together. And unless the parentheses exactly match, you cannot do any crazy canceling. So there's my final answer. X plus 3 over x squared minus 10. Okay, this next one, m plus 1, does not factor at all. It's already factored. And then on the bottom, I have a cube. So if you'll remember doing cubes, we take the cube root of each term, m and a 1 in this case. And then we do square, multiply, square. If you can't remember to do cubes, go back and watch my video on factoring cubes. We're going to square m so that we get m squared. We're going to multiply these two together. 1 times m is m. I'm going to square the 1. 1 squared is 1. And remember, the signs are same sign as I started with. So in this case, it was a plus. Opposite sign now will be minus. And then always positive is at the end. So I'm going to transfer that over here. M plus 1. And then m squared minus m plus 1. And you'll see the m plus 1's cancel. Now, when everything cancels on the top, it doesn't go away to be a 0. It cancels out and divides out to be a 1. So I have 1 over m squared minus m plus 1. And that would be how you simplify. You factor and cancel what you can. Okay. These next ones are going to look very similar except for their signs. We're going to need to be careful. If I want to change a 5 minus n, if I have an n minus 5 on the bottom, it is okay for me to factor out a negative 1 from that 5 minus n and change its sign to a 5 plus n. I'm sorry. Let's go back. That's going to be reversed. It's going to be an n minus 5. I'm reversing these two. So if you look at the first example here, I've got a 5 minus n on top, but I've got an n minus 5 on the bottom. Well, if I divide out a negative 1 up here, I can flip that around to n minus 5 so that then I can get them to cancel. Let's do one down here. On number 14, on the top, we don't really have to worry about too much with the top. I'm finding factors of negative 6 that add up to 1. So that would be x plus 3 and an x minus 2. Now, on the bottom, I'm going to do something a little different because I don't like factoring if it's not in descending order. So I'm going to write it negative x squared minus 5x plus 14. And I don't like factoring with the negative in front of my x squared, so I'm going to take out a negative 1 and have x squared plus 5x minus 14, and then I'm going to factor that. So factors of 14 that add up to a positive 5 would be plus 7 minus 2, and then I have that negative 1 in front. So x plus 7, x minus 2 with the negative 1 in front. And you can see those x minus 2's would cancel. But the answer is going to have that negative 1 in the front of it. Number of different ways you could write that, but you need to have the negative in front of that x plus 7. Now the next one is going to be different because you already have 2 minus x written. And you can't really do anything with that. So when I factor x cubed minus 8, that's a cube again. So small parentheses, large parentheses. The cube root of x cubed is x. The cube root of 8 is 2. We're going to square, multiply, square. X, when you square x, you get x squared. When I multiply these together, I get 2x. When I square 2, I get 4. And then I have same sign. This time it starts with a minus. Opposite, so that's going to be a plus. Always positive is going to be a plus. So I'm going to come over here and write this a little bit. If I have 2 minus x on top, notice on the bottom I have x minus 2. Well, those don't exactly match because they're not in the right order. If they had been addition, it would not have been a big deal. But with that subtraction sign, that makes it a big deal. So what I'm going to do, I'm going to do this in red. I'm going to take out a -1 from that one, and I can flip that around and make it an x minus 2. Now you can see those would cancel. So I'm left with the -1 on top, and then the x squared plus 2x plus 4 on the bottom. I'm not real crazy about these, so I don't do a lot of them, but just in case you encounter some on your homework, we need to know how to do these. So this last one that I've got up here, I'm going to look at factoring. Now, remember, anytime you're factoring, always go for a GCF first. On the top, if I take out a 2, that's going to leave me x minus 10. And on the bottom, I've got 10 minus x. Again, those don't exactly match. So what I'm going to do is I'm going to take out a -1 from that one. So I'm going to have 2 over x minus 10. We'll take out a -1 from the bottom and flip that around and make it an x minus 10. Now you can see the x minus 10s cancel. This one's nice because you've got 2 divided by -1, which will give me -2. And there is simplifying rational expressions. We talked about domains. Go back and re-listen. For anything you have questions about, email me with questions.